Okay, we're going to talk about phoronometry versus Planck's tone or Planck's tones. So this is about the blog post I just did on Fritz London's 1927 paper that Basil J. Hiley refers to. And Basil J. Hiley points out that Fritz London was actually the inspiration for Dirac's standard ket. And the standard ket is an algebra that's noncommutative. So if you're using a bra or a ket, you can only multiply from one direction, like left or right. So you're doing an algebraic process, but it's actually an operation in time as the order or the direction of the numbers of the arithmetic. And so the paper by Fritz London that I've dug out and read, it's 1927. So he's talking about de Broglie very favorably and in detail, which means he must have wrote it before the 1927 Solvay conference. I'm wondering if Fritz London was at the Solvay conference, but de Broglie came up with the pilot wave model that was also non-local, where you had a superluminal phase that's guiding matter. But as Basil J. Hiley quotes Louis de Broglie said this is just a simplistic solution that he's not satisfied with. And the problem has to do with Planck's constant. So, for example, the non-local David Bohm model that was essentially a rediscovery of de Broglie's pilot wave, was empirically validated by the weak measurement experiments with entangled photons. So they reproduced the double slit experiment, and they show that you have what they were calling, in the weak measurements, they're calling it a modular momentum, but it's essentially like a horizontal force that creates the wave field for a single particle going through two slits. And so this is the infamous experiment that is always studied for quantum physics, and Richard Feynman said nobody can understand it. But Basil J. Hiley said, he was never satisfied with Niels Bohr saying you just have to accept the statistical foundations of reality. And this is exactly what Fritz London is talking about in this 1927 paper. He's saying, well, Niels Bohr is telling us, it just has to be statistical, and you can't understand the foundation of reality. And Fritz London is emphasizing that the reason this whole problem is because of the Planck's constant is creating a discrete period of time in terms of the orbit. So if you think of frequency as angular momentum of the electron orbiting around the proton, so you're counting the cycles discretely, and then you get the photon absorption or radiation. So that's why Einstein got the Nobel Prize, because he showed the photoelectric effect, where you can empirically prove that Planck's constant is correct, that the frequency is directly proportional to the momentum, just as de Broglie discovered. So that's why de Broglie got the Nobel Prize. But de Broglie realized that there's this deeper thing that he called the law of phase harmony. So that's what the pilot wave was about, was this. There's this superluminal phase that's guiding the particle. But Basil J. Hiley points out, well, the problem is that a photon cannot have a zero rest mass by definition. And so you can't explain the weak measurement of an entangled photon in terms of what they're calling modular momentum, because you're assuming it has a relativistic rest mass. And so the irony is that Professor Peter Pesek, he gives a lecture on his book Music and the Making of Modern Science, and he has a chapter on Planck, and he details how Planck was working in music, and Planck actually wanted to go into music, and he was testing out a theory of Helmholtz that Helmholtz said if you had a group of singers, they would naturally go out of equal temper tuning by a half step of tuning. And this makes sense because the difference of the Pythagorean natural tuning with the equal temper tuning across the whole scale is a quarter step. So if you're going in the opposite direction of singing, or you're averaging the opposite tuning, I guess over 2 octaves, because you have the range of singers, then you get a half step difference in tuning. And what Planck discovered was that this was not true, that the choir maintained the equal temper tuning even though they were singing a cappella with no instrument accompaniment in equal temper tuning. And so this was called Planck's tone, or Planck's tones. This is what Peter Pesek, he goes into it in more detail, so I'm not doing it justice, obviously, but I'll link Peter Pesek's talk in the video description. So then Basil J. Hiley comes along, and he realizes that Einstein was studying what he called phoronometry, which is a motion without any cause. In other words, you have a motion with no thing or no matter causing the motion. And this was considered to be a dynamic geometry. So what Basil J. Hiley explains is that when you're looking at the double slit experiment and you get that wave, the wave is like the collective behavior, but it's not really a wave. There's this deeper future and past as a non-local time. And it looks like a force, but it's actually this dynamical geometry. It's geometric in the sense of you're changing the direction of the future and the past. So it would be, in terms of space, it would be backwards and forwards. But it's actually in time as the future and the past. And so this Basil J. Hiley, he was wondering, well, why was David Bohm's physics rejected as the true ontological understanding of reality, the foundation of reality? And they were pondering, well, was it because of his, communist affiliations because he was interested in the collective over the individual in terms of his study in physics on what's the word? I want to say lasers, but it's not lasers. Anyway, he's plasma physics, and I was thinking phasers. Like, I know it's a P word. So, so Basil J. Hiley says, well, it's not really the collective as much as it's the context, because this is going on before space-time exists, and it's in pure time. And so I think the reason it was rejected is because the foundation of Western science is based on converting time into a spatial measurement. And so it's a very deep, what math professor Luigi Borzicchini calls a cognitive prejudice from Platonic philosophy. So that equal temper tuning that Planck relied on to create his Planck's constant, it arises all the way from Archytas and Philolaus, as I detailed in my peer-reviewed published article. So you have the same error inspiring Planck's constant, but then Heisenberg discovered that it's actually the order of the overtones in spectrometry for the photon emission and absorption, and this is what Alain Connes goes into in his Music of Shapes talk. So Alain Connes proves that the truth of music is actually what he calls 2-3 infinity, which is this noncommutative time and frequency that's nonlocal. And so my own research goes into that's also the secret of non-Western meditation as the truth of reality. And so Basil J. Hiley in this talk that I'll link in the description, one of his last talks, it didn't get posted until after he passed on this past January. So it's a talk he gave a couple of years ago for the Pari Center out of Italy. I'm not sure why they didn't post it until recently, but at any rate, he keeps talking about phoronometry, and then he mispronounces it because he likes to call it phorometry, and so then he actually changed the spelling of the word to phorometry halfway through the talk, and then he changed the spelling back to phoronometry, and then he's like, well, I struggled to pronounce this word. And he makes like the best jokes throughout this talk. He's like, he cites a paper from 1894. He's like, well, I'm trying to keep my research current or whatever. He's like, everybody would know this word back then, in 1890s. I think that was Einstein's source for discussing that term phoronometry. I looked that paper up, actually, that 1894 paper. But, so anyway, so Basil J. Hiley, he goes into, again, how when he was in Finland, a Finnish PhD student in music came up to Basil J. Hiley and said, I need to talk to you about phoronometry. And so Basil J. Hiley's like, yeah, they study this in music, it's phoronometry. And it goes back to this Greek concept of motion without a cause, without a, cause in matter. And of course, an easier way to describe this would just be listening. Who is listening? What's the source of listening? Listening as a process in music that takes you into meditation through these complementary opposites that I've gone into in detail, in terms of the music theory. So I'm not going to go into that, but Yeah, so I don't think that Basil J. Hiley, or I don't think a lot of physicists realize that Planck was directly inspired by the wrong music tuning. And then the people that know that don't realize it is the wrong music tuning because they don't know about Alain Connes' talk on how the truth of music is this non-commutative secret. And that's the same truth that I realized when I was in high school studying music. So I'm glad that Basil J. Hiley was focusing on music. And in fact, in his work with David Bohm, they use music as the clearest analogy of what they're trying to explain. And Basil J. Hiley uses the word anticipation. And so when he's talking about the forward and backward derivative as a change of direction, that goes right back to that Fritz London paper he cites in 1927, because Fritz London directly says that the momentum has a change in direction without changing the magnitude. So in terms of music theory, you can think of the three as the magnitude, but the direction changes as an overtone and undertone. So as an undertone, it's 2/3 as C to F, and then so the 3 is F, and then as an overtone, you have the same magnitude as 3, but it's 3/2, so it's a G, C to G as the overtone. So you have 3 equal F and G at the same time as the order of the overtones and undertones. And so this was not allowed in Western tuning, even though it's empirically true, as the non-commutative truth of reality. And the reason it wasn't allowed in Western tuning is because they're trying to explain music as an external measurement using an instrument with matter, but that's not what listening is. When you listen, you have that inherent anticipation. This is what Bohm and Hiley talk about when you listen to a musical sound. You have a memory of the previous notes and then an anticipation of the future notes based on the natural resonance of the overtones and undertones. So that precisely is this non-commutative secret. And they don't go into the details because they don't know it, because they're not trained in music. So I was very happy to see them discuss that process. And they got that from Bergson, I think. Well, they might have got it from they probably got it from Whitehead, because Whitehead got it from Bergson. So that's the lineage, because when I had my article published, they're like, why aren't you citing this one Czech professor of physics? And he has the same point, but he's talking about, he's got it from Whitehead, or he got it from Bergson, but from Whitehead. Yeah, so. And relating it to Bohmian physics. So there you go. Yeah, so I did get it. I got my article published because of that same connection. That's actually the secret of non-Western music theory as meditation. And Eddie Oceans figured this out. He didn't connect it to the music theory, but he figured out that the non-commutativity is the secret of non-Western meditation as a mind-body integration, doing standing meditation. And so that's pretty much all I wanted to say. Well, and then of course Basil J. Hiley in this he's like, well, you would not have evolution if you rely on this classical physics foundation of reality, because it doesn't allow an explanation of an inherent motion of reality as life. And so that of course explains our ecological crisis. And he didn't say that outright, but he and David Bohm did say that in other places, that what Bohm was describing was inherently organic, and that our ecological crisis today is due to this wrong understanding of physics. So, yeah, it's a great feeling to think that David Bohm, and Hiley really carried on the work of David Bohm, and Hiley did a great job in discussing this and figuring it out. And I feel honored that I was able to be a part of that discussion, because he asked me some questions about Alain Connes. He asked me a question about Alain Connes' talk. He promoted Alain Connes' talk in Hiley's last public talk that he gave on YouTube, which was posted in the end of March, or the end of 2024, I think, the fall of 2024. So he did awesome work, and yeah, it was very interesting, because I first contacted him about, I said, time and frequency are noncommutative. And that was the start of my correspondence with him. And I like how he said, no question is a stupid question. He repeated that philosophy. You hear teachers say that sometimes, but most of the time teachers don't really follow that philosophy. But I think he really did. He was that open-minded, where he just appreciated people being sincere. And he's joked, made some great, awesome jokes. So, anyway, we will. He has people carrying on his research. So, I just wanted to emphasize the music connection of the phoronometry. Well, sometimes he says it's phoronomy, but then he pronounces it phoronomy. Now I can't say it. Phoronomy. He leaves out the whole last phoronometry. Anyway, so you can call it phoronometry or phoronomy, and then you could spell it various ways. Okay, we'll leave it at that.